We say that relative velocity, I want to start, we are going to be entering motion soon, but I want to start motion class with relative velocity. I have my reason, because it still touches some part of vectors. I say relative motion, or you say relative velocity, we normally call it relative velocity. Is the motion of one object, is the motion of one object as observed by another moving object. Relative motion is the motion. Relative motion is the motion of one object as observed by another moving object. Please, this is a new topic, fresh topic. We're entering kinematics. But I said before kinematics, I want us to touch relative velocity. Why? Because the concept of this relative velocity is very much related to vectors. I want to use it to reteach vectors. Then we know that in our next class tomorrow, we are entering kinematics proper. I want to make an announcement. Okay, so please, when we talk about this relative velocity, I need you to know that there are two keys. One, it is when it is moving in one direction. And two, it is when it is moving in two directions. Another name for it is two dimension, not direction. We say one dimension, two dimension, sorry. One dimension, two dimension. So please, when you hear two dimension, it simply means either vertical and horizontal. While when you hear one dimension, it simply means maybe I am moving this way. And another object is moving this way. For example, as you are seated in the bus or inside the bus every morning coming to Amechi, you notice that some buses are moving from Esut back to Amechi, Shebi. So you are going this way, another one is passing this way. Is it not true? That is one dimension. That is one dimension. But let's say we normally use these examples, and these are the examples we'll meet as we solve this. Let's say you are trying to cross a river, and that river is flowing this way. You are crossing this way. Shebi, you see, this is two dimension. Is it not? Yes. Now let's say you are inside bus, and they decide to remove all the seats inside that bus, and you start running inside that bus. That means the bus is moving this way. You're also moving this way. Is it not true? Yes. So we normally say that when it is one dimension, we are considering are they moving in the same direction or in opposite direction. So please, we are going to be taking questions from your new physics or workbook. So, or in opposite direction. I will rush to this class. I notice we try to cover, then we end up, in trying to cover, we end up being too fast. And some people will say they don't understand. But I see, if it is in the same direction, let's say this one is moving in 5 meters per second. And another object, let's say a bus going to Amechi moving in 5 meters per second. Another bus going to Amechi moving in 3 meters per second. Now, let's say a bus going to Amechi moving in 5 meters per second. Another bus going to Amechi moving in 5 meters per second. So please, the rule of thumbs is that when it is moving in opposite direction and you notice that it's in one dimension, that all you need to do is for opposite dimension, the relative velocity is simply, if this is A, velocity of A, and this is velocity of B, simply do relative velocity to be VA plus VB. When they are moving in opposite direction and it's in one dimension, you add up. See what it means. See now. This thing is moving this way. With my eye, I notice another bus is moving this way. That means the relative velocity or the velocity due to this one moving is simply, as it's going this one, it's going this way. My eye is noticing my own distance and this one's distance. Is it not true? Yes. But when I am moving this way, let's say I am in a bus moving this way, and another bus moving with us is moving this way. what I'm noticing is that I am moving this way, this one is moving this way, but mine is faster than this one. Is it not true? So I have this distance to check. So we simply note that when it has to do with same direction, we say that relative velocity will simply be equal to, if this is velocity of A and velocity of B, it will simply be VA minus VB. So note it. So for one dimension, same direction, you are subtracting. While for one dimension, opposite direction, you are adding. That is the first. So now let's look at when it is two dimension. We are just giving you notes and explaining the notes so that we can now go into solving the question. This is a very simple topic, it's very short. So we treat it quickly so that we can do maths. So tomorrow we now enter kinematics, or you call it kinematics proper. So for two dimension, relative velocity for two dimension. So when an object is moving, let's say your river is flowing this way. Please pay attention. This is where you need to learn the basics. If the river is flowing this way and you are trying to cross this way, once you look at the question and you see cross or across, as you start solving question, if you hear across or you say cross river, somebody is trying to cross river, or maybe across, notice that they are talking about the vertical axis. Also notice that if you hear helicopter is moving, river is flowing, that they are talking about. So I said, if they say river flowing, Shebi, hope I'm not too fast. If they say river flowing, let's say helicopter, all those objects that are moving ahead that we normally use here. So if you hear river flowing, or maybe currents, or you hear downstream, however they say it, note that they are talking about the horizontal axis. Because we'll be solving questions from that your workbook. You'll now see the implication and the application, and we'll try to do the vector parts, so that those of you that joined us newly will be able to follow up. But if you hear upstream, it is still horizontal, but opposite direction. So if a river flows downstream and is this way, upstream simply means it's going horizontally, but in opposite direction. Now, if you hear a boat, if you did not hear across, remember I said if you hear the man is trying to cross or something, let's say a helicopter is moving and the ball is rolled across, it simply means helicopter moving horizontally, ball rolled vertically. But if you hear a man is trying to, or should I say swim, or a man is swimming and his boat, and another man with a boat tried to, should I say, row his boat. They did not use cross. Row his boat, however they want to put it, but you did not see cross. It simply means that cross is very important word. It's either you are using, instead of using vertical here, they use cross. What it means, if you hear row boat or whatever happens to boat, what they are just saying is that boat is this way. So if this is the horizontal axis, the boat they are talking about, whatever velocity they give you there is at the diagonal. So it simply means that to row boats is simply the diagonal. Is equals to diagonal, or you say hypotenuse. Simply the diagonal, or you say hypotenuse. Now, whenever we are talking about relative velocity, please, I want you to be taking note of all this. Whenever we are talking about relative velocity, if I know that this is the vertical component, and this is horizontal component, and I know that there is something like this, which is boat, Shebi. This one means across now, is it not true? This one means maybe river flowing or whatever. So this one is like my boats. Now, if that be the case, the angle, we normally, please, somebody wants to ask me how did you know? Please, it is a constant. The same way I told you that when you have your pendulum, Shebi, we said that the angle for your pendulum is with the vertical. Is it not true? We also said that when it has to do with inclined plane, that we take angle with the resultant to be the vertical, which means that y will be cos theta there. Is it not true? If that is the case, if I have a river, notice, if I have this river to be flowing this way, this is what we said, though. Shebi, you know, flowing this way. It is going this way. That is when it's going downstream. And anybody is rolling his boats, and they did not tell us that the man is rolling his boat this way or this way. We are now saying that the angle, whenever it has to do with relative motion, that the angle is always with the vertical and not the horizontal. Just note it. As you start solving questions, you see us applying it. The angle is always with the vertical and not with the horizontal. I hope you are taking notes. So angle always with the vertical and not with the horizontal. So if I know all this, I want us to go to our new physics workbook. I did not post it today, and I'm already using my phone. But if you go to your new physics workbook, I think from question 13 down to 19, thereabouts, it centers, it revolves around this relative motion. Everything there is around relative motion. And please, the last thing I want to teach you before we start solving questions is this, please. Before we start solving questions, have you noticed that most times when you want to find angle, you normally do something like this? 0, Shebi? 90, Shebi? 180, is it what you normally do? 270, Shebi? Then you do 360, Shebi? This is what you normally do now. Is it not true? They tell you that angle is positive when it is moving anti-clockwise, right? But there's something we call bearing. And that bearing is always given in 3, should I say digits? Let's say I want to write 90 for bearing, I will do 090. If I want to do, for example, 45, I can't write 45, I write 045 degrees. You've heard of bearing before. So what they are saying is that when it has to do with bearing, because I saw it in the questions you have there, because we'll touch all those things. What they are saying is that in that case, what you need to note is that if this is north, do you agree? And this is east, and this is south, and this is west, that when it has to do with bearing, that you should start from north, make north to be 0, and move clockwise. So that I have 0, Thank you. This is all about bearing, but notice something. If I want to make it 2, I will come and put 0 here. So naturally, it always falls into 3 digits. So if somebody tells you a bearing of 150 degrees, that person is simply saying, start from here, run here, and you see that it falls within this. Is it not true? If I want to write this, I can say that this is the sentence saying 150 degrees, the true angle. Or I can say, notice something. This angle here is now what? 30 degrees, Shebi? Hope you know what this thing means. This is the sentence saying 90, Shebi? Plus 60, you see? 150. So, you remember this, everything here is 90 as well. So, or I can say, or, remember that this one is south. And this angle is here. That time we did direction. Direction of angles. S, this is 30 degrees. Shebi? East. So it means that this is east of north, east of south. Hope you know. East of south. That is southeast. That is the part with the angle. That is where you start first. So if you don't write it this way, you write it this way. So this stands for true angle. This one is a convention. So if we've noted this, let me see that new physics one. Can I clean? So that we can look at those questions there. If we are done with those questions, we do maths. Let me just see your. So for 2 dimension, whenever we have 2 dimension, in order to get what we call the track, another name for track is what we call direction. In order to get what we call track, we use either the Pythagoras, depending on how the question comes. We use either the Pythagoras or we use the component method. we'll see it. So I said, whenever we are given in 2 dimensions, to find what we call tan, we use that our Pythagoras now that we later resort to. And you know that anytime we use Pythagoras, we normally end up using tan with shading, or we use component method. So we'll solve questions so that we'll prove that one. It's not something we explain without question. So notice question 13. We'll solve from 13. We'll solve from question 13 down to it should be question 18. Yes, it should be question 18. So we'll observe, yes, I've noticed, yes, this person got it right. You notice that 18 is wrong. That 53.13 is wrong. The correct thing should be 36.87, and she already did that. Correct. So from question 13, they said a river 50 meter wide. A river 50 meter wide. Can I clean? A river 50 meter wide. I've explained the things I can explain. So the remaining, we do it with questions. A river 50 meter wide. A river 50 meter wide. A river 50 meter wide. Next question 13, new physics workbook. A river 50 meter wide. These are the type of questions that during secondary school, good number of you will want to be killing yourself for. So I want us to first do this so that when we now enter mechanics, we don't have issues. So if you have any questions as we progress, you call me. Don't allow me pass. Why you calling me back? What I've just given you are just formulas, things to note like keys. So as we start solving questions, it become more clear. So a river 50 meter wide. Well, see what I'll just be doing. If the river is 50 meter wide, naturally I know that anything about river flow is horizontal shaping. Let me just write 50 meter. Now, is flowing due east. Is flowing due east. At 30 meters per second. A man wishes to row his boat due north across the river. In this type of questions, what you'll be seeing is either you see row or you see cross. Can you hear me? If you don't see, once you see cross, know that they are talking about right angle, perpendicular. You are just going to use the second formula I will show you when we are solving it. But once you see row, you are using this one I'm going to teach you now. So a river 50 meter wide is flowing due east at a velocity of 30 meters per second. These things are easy. You already did it in secondary school. But for the fact that we are here for learning, we'll touch everything. So a man wishes to row his boat. I told you that once you hear boat, that boat is diagonal shaping. Wishes to row his boat due north across the river. Yes. Due north. I know that somewhere here is ending now. Due north. Now, if he can row his boat in still water, still boat, so, then 50 meters per second. Now they are telling me, calculate the direction in which he must head his boat. Calculate the direction in which he must head his boat. Do you remember that this side is called y-axis? Do you agree? Do you agree? Okay. I said, a river 50 meter wide. A river 50 meter wide is flowing due east at a velocity of 30 meters per second. A man wishes to row his boat due north across the river. If he can row the boat in still water at 50 meters per second, calculate I the direction in which he must head his boat. Calculate I the direction in which he must head his boat. Calculate I the direction in which he must head his boat. Should I continue? I. The time taken to reach the other bank of the river. I, the time taken to reach the other bank of the river. Let me start it from the beginning. A river, 50 meters wide, is flowing due east at a velocity of 30 meters per second. A man wishes to row his boat. Now, please notice something. Do you notice that? Hope you notice that this thing that he's moving here, if we remember equilibrium, as he's here, this thing is also here. Do you still remember? Yes. Equilibrium, right? Okay. As well. I'm just drafting, I'm not using it, I'm just showing you. So, a river 50 meters wide is flowing due east at a velocity of 30 meters per second. Full stop. A man wishes to row his boat due north across the river. Full stop. If he can row his boat in still water at 50 meters per second, full comma, calculate I the direction in which he must head his boat. I, the time taken to reach the other bank of the river. So, if I know this, I've posted this new physics workbook several, but if you don't have it, you can snap your friend's own. See what we are saying here. Whenever you did not hear cross or whatever, you hear rowboats, or even if it's helicopter they are talking about, even if it's helicopter, and you did not hear that the helicopter, that the person inside did anything across, you hear how can he drift or whatever. This thing you see here that is diagonal is more like drift. He's trying to tell you that if the man is trying to move from here to north, that he will be drifting. It's not like he's moving across directly or opposite. He's trying to, as he's doing this, he will be shifting. So he's drifting. We'll take it as diagonal. Whenever you notice that this is not pointing to being straight to perpendicular, the formula to use is simply to remember that angle made is with what? The vertical. Very important. And you remember when I taught you this, that time we started, I said if this is y, and this is x, and this is theta, if I want to do sine theta here, it will be opposite of hypotenuse, Shebi? And the opposite here will be what? The side facing the angle, right? It will be x, and hypotenuse, right? Let's say I call this r, is it not? So that I will now have r sine theta is equals to what? X, is it not true? Shebi? Hope you are saying something. Now, if it is cos, if it is, I don't want to clean this thing, we'll use it later. If it is cos theta, it is the same thing as saying adjacent over hypo, which is equals to, what's the adjacent here? The side that is not. So, y over, so that I will now have that r cos theta will be equals to what? Whenever you are dealing with relative motion, I said that angle made with y-axis, or you say the same thing I told you about simple harmonic motion. Sorry, yes, simple harmonic motion, simple pendulum, inclined plane. Add relative motion to it. That the y is always cos theta, and the x is always what? Sine theta. Very important. So notice something here. If I use the same thing, I want to use these two things to check something now. This is x, Shebi. What is the x here? On the x, notice that the velocity I have here on the x is 30 meters per second, Shebi. Let me just write that 30 for x. X equals to. Now, r, that is the resultant. R here, what is r here? 50, Shebi. Hope you are agreeing. Now, I have sine theta. But do I have theta? I don't have theta. What I can do now is to make theta subject of the formula. By doing divide both sides by what? 50. So you see that this will take care of this. So that sine theta is equal to 30 over 50, which is the same thing as 3 over 5. So if I make theta subject of the formula, hope you can see the board from the back. So if I make theta subject of the formula, I should have sine inverse, Shebi, or arc sine. 3 divided by 5. 0.6. Or you do for me sine inverse of 0.6. 36.8 That is, theta is approximately 37 degrees. Is it what you have? So please, somebody says, sir, I don't understand. Now see, first of all, you know that when we are teaching, it's looking as if you need to think like this, think like this, think like this. The only thinking I want you to think here is that whenever it has to do with relative motion, and how do you know it's a relative motion question? You will know it's a relative motion question from what they are telling you. Two objects are in motion here. It's not like when they tell you a car moves from, and this one did, and now has to come to rest, and this one. So two objects or two persons or two things are in motion here. So whenever you have two things in motion, the first thing you need to think of is what we call relative motion. It must be there. So the motion of a body, the motion of a body due to the observation of another body in motion is known as relative motion. You can easily say it is simply the motion of a body due to another body's motion or due to another body's motion. Hope it's making sense now. So I am not saying that once it's relative motion, you need to know that angle is made with the vertical. And when angle is made with the vertical, what you just need to do in this case, somebody can choose to say, okay, what if I want to do r cos theta equals to y? Now, if I am to do r cos theta equals to y, notice that on this y, I have no value here. Shebi? But we can choose to get y. Hope you know we can get y. Because if we choose to say that in as much as, yes, there's angle here, that this is still 90 degrees. Are you aware? I can use Pythagoras to get y. Open your eyes. Can you see? See, look. So let's try to see if we can get y. So that I will now say that 50, that is, you know that r square now is equals to x squared plus y squared. Do you agree? So that I now have 50 squared is equals to 30, Shebi, plus y squared. I don't know why. So if I do 50 squared is what? Is it 25? Is it 25? 30 come? Okay. These ones are easy squares. So I will now do this crossover. I have 500 minus Shebi equals to y squared. Watch for me. 1600 equals to y squared. But if I take the square root of both sides, I have that y is equals to what? 40. Is it 40? 40 point what? Okay, just 40. Okay, and you know that what I use in doing this is velocity, Shebi? So that means that y is 40 meters per. Oh, somebody somewhere is just sweating. Get him down in medical. Panic not. Hello? Panic not. If you are not following, as you are through with this first example, I will give you one that you will do for me. Then as you are doing that one, we'll still solve it together. By the time we solve it together, you must learn. Are you following this class? Thank you. Okay. Well, see, let's check something now. Do for me now. See, please, let's do it together. Let's say, we know that r cos theta is equals to y, Shebi? Let's say the arrow there is what? What's the arrow? 50, Shebi? Cos theta, I don't know theta, is equals to, the y now is what? 40, Shebi? Okay, now let's do divided by 50. So this, we cancel this. And notice something, hope you know that if I am doing this theta now, that is this theta, that means that should be the angle with this side, is it not? Okay, let's finish before we start checking that. So I will now have this go over here. So 4 over 5 is what? 0.8. 0.8. Can I clean this? Okay, let's do it here. So I now have cos theta equals to 0.8. Do you agree? Theta is equals to cos inverse of 0.8. What do you have? So theta is equals to 87. Theta is approximately 37 degrees, which is the same thing we got in the other one. Is it not? Yes. So our theta in that case, watch here, please. Our theta is the same. I made that mistake of trying to say that it's something here. No. Reason being that, remember that we are putting this side to be y. Is it not true? And we are putting the other side to be x. So it simply means what it's trying to say is that whatever you do, provided you are using the y part, it should give you the same theta. Provided you are using the x part, it should give you the same theta. You are confused. Let me say, you don't understand. Okay. Okay. Now, can I clean everything? Yes. Copy. Please, the only thing I just want you to get, remember I've told you naturally, when dealing with vector, x-axis is cos theta, Shebi. Y-axis is what? Now, when dealing with pendulum, inclined plane, and relative motion, x-axis is what? Y-axis is what? That's the only thing I want from you. Every other thing is not simple. I said, when dealing with vectors, x-axis is cos theta, y-axis is sin theta. But when dealing with pendulum, that is simple pendulum. When dealing with inclined plane, relative motion, x-axis becomes sin theta, y-axis becomes cos theta. Reason being that angle is made from the vertical and not the horizontal. Anytime angle is made with the vertical, x-axis becomes sin theta, y-axis becomes cos theta. So please, let me give you another, but we are not through with this question. Hope you know. Yes, we've not gotten the time, Shebi. Ngwana. I will give you, let's finish with the time. I will then give you another one. You will try to solve that one. If you don't get it, we'll solve it together. As we are solving it together, you try to pay attention. You understand? You are in tutorial class. We are not running to anywhere. It's up to you to say when you want us to go home. Left to me, you will not believe it until when your exam starts. If there's anything like teacher-thon, I deserve one. When you start your exam, there's something we call marathon. We'll start class from 9. One person will be teaching you from that 9 till 4. You check time, you say, sir, it's 4. Yes. So please, fear not. Let's do the time. Then I give you another one. You try to solve it. If you don't get it, we'll not solve it together. I ask. And we'll come to that now. That is why I drew something like this. That is why I drew something like this. So we'll get to that part, showing you what is this one. We've done it in vector. We'll get to that part. But I want us to quickly finish the time. I give you one. We'll do all those ones. Hapo father that one. So I said, to get time, please, to get the time, it will take. Please check the question. What did they ask us exactly? Time of what? Time to reach. Okay. Shebi, you know this is the river now, Shebi. The width, right? Now this man is trying to move from this place to this other end. Is it not true? So he's trying to move from here to this end. So they are asking us the time for him to move from this place to this place. Is it not true? And what is the distance from this place to this place? 50. Let me write it out. 50. 50. Nekwaya, just watch. Notice. He's moving from here to here. Shebi? But notice something. He didn't actually move like this. Shebi, you know he did not move like this. Shebi? What he did was that he moved this way. Shebi? And in doing that, what has he done? He has covered this distance upwards, right? Is it not true? Yes. So what you just do is to say 50 divided by that vertical distance, which is 40. Punch it from the other. 1 point. That is how you calculate time. That is how you calculate. You say you don't understand. Yes. What don't you understand? Okay. Okay, I should give you the formula. The formula is simply, the formula T is simply the horizontal distance. The horizontal distance. Please, first of all, S is equals to UT, Shebi. Is it not true? And if S is equals to UT, if you make T subject of formula, which is the formula? T will simply be equals to S over U. Shebi? This is the formula. So notice that, but what you are now using is that the velocity you are using is the velocity of the vertical axis. Because this is the axis that you covered. Are you seeing it? That is simple, very simple. So still from velocity formula, S equals to UT, T equals to distance over time, distance over initial velocity. So what you are just doing is you are saying the 50, that is the distance. He's moving from here to here, but he had to go from here this way. So what you are checking is from this end to this end, and he covered this distance up. And that thing he covered up is actually a velocity. So this is the formula. From displacement equals to initial velocity times time. Make time subject of the formula. So what you just need to write for me here is just to say the initial velocity you are using is the vertical velocity. And the distance you are using here is the horizontal distance. If you like, let it not enter your head. I'm not doing any magic. What I'm doing is the regular thing we know. The only thing is that I started this relative velocity first for a reason. Because it has that relationship with equilibrium, vector, and motion. So let's finish that concept. We'll get it, then we'll move into kinematics proper. So let me give you one to solve for me. 40. Is it not 40 that we did together here? Is it not the 40 we did? Can I clean this? Hey! Jesus! I'll be teaching people who will be sleeping. See now, have you forgotten when we started that we did something like this? And we ended up getting that this boat, velocity of boat is always on the diagonal. Do you agree? River flowing is always on the horizontal. And they gave us 30 meters per second for it. Shebi, using Pythagoras, find me this side. You do it. Using Pythagoras now, find me this side. Some people, do you know what some people do? Once they don't see angle, and they see something on the hypotenuse side, they take it that the triangle is finished. Nothing to do again. But please, you can do something here, or you try and do it. Using Pythagoras, try to get me this side. Let's see what you have. So I will give you one, like this one now. You solve for me. Once you are done solving, we solve it together. Then we now take another case. This is what I call case one. Case one is simply when the boat is drifting. So you can just go on top of it and write when boat drifting. So it is not when boat moving perpendicular or when boat moving to opposite side, but rather when boat drifting. So he's trying to move, but it is not moving straight up to the north. He's maintaining an angle. So that is what they say whenever you see rowboats, and that is a case of boats drifting. It's in tutorial class they impregnate you academically. Should I have told you before? Yes. When you go home, you'll be very happy, provided you ate before coming. You will think it's small talk when I say eat before coming. That thing is a very big talk. Because some people, as they are here, they are managing to be here. Yes. Food, very important. Fuel, very important. Don't ever joke with it. I have taken exercise 2. Because of the way physics is, if you notice, it's not something you solve without making you understand. So we solve and we have to make you understand. So try to solve this one for me. If you don't get it, we solve it together. But one thing I want you to understand about this physics is that what you are building is experience. As you are solving each of the questions, you will not be noticing that this is a case like this. This is a case like this. Why is it like that in physics? This is because these are things that happen normally. is called physical activity. That is why we say physics is the science that deals with the environment, matter, and environment around it. So when we are doing physics, it's not something you just say, I have to be very, like should I say, I bend like this, I bend like this. No, you just have to understand each case. What is this case? What is the case about this one? What is the case about this one? So let me give you, using the same question, something similar. Something similar to it, so that we now solve it together when you are done. Then continue. Okay, number 18. We'll solve all the questions there from that 13 to 18, but I'm giving you ones related to this case. So as we are doing it, you are using style to do your workbook. So if you do not understand this one, pay attention now, you must understand this one. A river flows at 3 kilometers per hour. The river flows at 3 kilometers per hour. The river flows at 3 kilometers per hour. And its parallel banks. The river flows at 3 kilometers per hour. The river flows at 3 kilometers per hour. The river flows at 3 kilometers per hour. And its parallel banks are 400 meters apart. And its parallel banks are 400 meters apart. The river flows at 3 kilometers per hour. And its parallel banks are 400 meters apart. The river flows at 3 kilometers per hour. Once I finish the whole class, I now summarize. I give you the 3 things you need to know for the 3 cases. The river flows at 3 kilometers per hour, and its parallel banks are 400 meters apart. The river flows at 3 kilometers per hour. The river flows at 3 kilometers per hour, and its parallel banks are 400 meters apart. Are 400 meters apart. A man wishes to cross in a motorboat. They did not say man cross with a motorboat, should they? They said wishes to cross. Okay. A man. Okay. I said, please, that wishes to cross is the same thing as saying, that wishes to cross is the same thing as saying, the man is aiming for the north. But it's not that he moved due north. Can you hear me? So you don't come and say because you saw cross there. The man, academic guy said if you see cross, 90 degrees. No. Pay attention to the boat or the movement medium. So if they tell you that medium crossed or moved across, that means they're just telling you, instead of doing that your diagonal, you are aiming 90 degrees with the river. But this one, he wishes to cross. Now, see the next thing. Wishes to cross in a motorboat, which can make a velocity in still water. So it can make a velocity in still water. So a man wishes to, can I claim this? Let me start from the beginning, please. Let's be fast. A river flows at 3 kilometers per hour, and its parallel banks are 400 meters apart. A man wishes to cross in a motorboat, which can make 5 kilometers per hour in still water. Let's go again. I said, a river flows at 3 kilometers per hour, and its parallel banks are, a river flows at 3 kilometers per hour, and its parallel banks are 400 meters apart. Full stop. A man wishes to cross in a motorboat. This question is on the channel already. All this thing we already is taking our time. Which can make 5 kilometers per hour in still water. To reach the point directly opposite. Find I the direction in which he must steer. Find I the direction in which he must steer. Find I the direction in which he must steer. I the time taken to cross the river. I will advise you, once you are doing this type of question, to avoid trouble. You will see that they gave you kilometer, something in kilometer, they also gave you something in meter. Is it not true? Check now. They gave me, look at what they gave me. They gave me the river flows 3 kilometers per hour. Is it not true? And apart, that is the distance from here to here is what? 400. And it's in meter, Chevy. Now, a man wishes to cross in a motorboat, which can make what? Do you remember that the boat is diagonal? 5 kilometers per hour. Okay, in still water, watch out. To reach the point directly opposite. Now they say find the direction in which he must steer and the time taken to cross the river. Please, do you know what I want you to do for me? This 400 meters, if you convert it to kilometers, is what? Hope you remember that 1 kilometer equals to 1,000 meters, Chevy. That means if I have 1 kilometer equals to 1,000 meters. I've done this when we started. Now if I have 400 meters equals to X kilometers, Chevy. And I want to convert to kilometers, is it not true? Because I'm noticing this in kilometers, you don't see kilometers. Only one thing in meter. Do you understand? Yes. So let me take it to kilometers. So I will now say that this is the something I said. Let me cancel the Chevy is kilometer I want to take it to. So S kilometer, I'm writing meter. S kilometer. So let's cross over. This becomes 1 kilometer, 400 meters. Please, those of you just starting, it's because of you I'm redoing this. Now 1,000 meters, X kilometer. Meter, cancel meter. So if I am making S kilometer subject of the formula, I will divide by 1,000. Divide by 1,000. This will cancel this. If 400 is divided by 1,000, what do you have? 0.4. Please, write it here. Anytime you see that distance, don't ignore it. That distance is what you will use to calculate your time. Because distance is the same thing as displacement. Don't worry. Displacement with direction is what we call, distance with direction is what we call displacement. Don't worry, we'll do kinematics. I will explain all those things for you, like from the beginning. Now, if that be the case, let's now go to answering this question. So that you see why, using our approach, the same approach, please, do you remember? Please, do you remember that y is equals to what? So from y is equals to r cos theta, Chevy, and x is equals to what? Chevy. If we use that same approach, that means that if I'm looking at this, so watch you. That means that if I'm looking at this, x here is simply what? 3, Chevy, kilometer per hour. Are you seeing it? I've drafted it. Equals to the r is the diagonal side now. 5. Now sine theta. Chevy, if I'm making theta subject of the formula, I will now have divided by 5. Divided by 5. There's something I want us to pick here. Why you will see the other formula, then I now tell you. Okay, let's finish. I'll have this and this. So if I am making theta subject formula now, this is now sine theta is equal to 3 over 5 is what? 0.6, Chevy. Theta is not equals to sine inverse of 0.6. Shebi? But notice something here, please notice something. If you do it, you're getting the same 37 degrees now. Shebi? But watch something. Watch the impression I want us to correct now. If I do for y equals to r cos theta, notice that y, we don't know it, right? Equals to r 5, shebi, cos theta. Is it not true? See what your textbook did. The reason why they got 53.13. They replaced this with 3. And you know that this y is not 3. Shebi? But let's check something. If I do this divided by 5, divided by 5, let's check. So this will cancel the shebi. So cos theta is equals to 0.6, right? Theta equals to sine inverse. Okay, wait, Jesus. Obiakwana. Cos inverse of 0.6. Aya, here for me. 53.1. This is what the person that did this did. Can you hear me? And that is what he puts there. So he failed it. Do you know why? Y-axis is there. Is not 3. Can you hear me? Y-axis is there. You can see it now clearly. Y-axis there is not 3. But see what he was considering. What he was considering is that anytime you hear directly opposite, he was considering that anytime you hear directly opposite, you should use x. Yes, equals to r cos theta. Can you hear me? This is the correct answer. But he was considering the conventional method of once you see directly opposite, that you should use x to be equals to r cos theta. So if you are marking it and the examiner is marking this, this is what it should be. So a conventional approach in physics, advanced level physics, is that once you hear directly opposite, use your x. That's normally we know that x is equals to cos theta, Shebi. Use that your normal x, normal convention. But please, when you are solving physics for this, your year 1 level, this is your answer. So I'm teaching you both ways so that you know. When you come across it, it may be, in all those your 200 level, 300 level as you progress, you definitely come across, if it's directly opposite, remember that x is equal to r cos theta. But please, for this level, nobody is teaching you this. What we are teaching you is that x equals to r sin theta when we're doing a relative velocity, and y equals to r cos theta. That is why if you type it in ChatGPT as well, this is what they should give you. Even though I don't support ChatGPT, I support you learning it well, but they should give you 37 degrees. So please, let me now give you another one. That is case 2. Yeah? Okay, I've not found the time. I'm trying to hurry so that we can do maths. How is it that it's x? We use x because that is what we are given. Now we are giving x here to be 3. Are you not seeing it? We are using x to be 3 now. X, this side is 3. So I'm saying that by the time you do this, remember that our angle is always with this. Now, is it not true? If you do it well, it should be by right. If you do it by the normal convention, it should be x equals to r sin theta. That is what it should be. But we are not saying that as you progress, in fact, I don't want to be saying that. So this is what you have. Yes.
Sir,
okay.
what about that cross? I thought you said cross is vertical.
Cross. That means you are not paying attention. I said wishes to cross. The man wishes to cross. Wishes to cross. His boat did not cross. Read that question. A man wishes to cross in a motorboat. Shebi? A man wishes to cross in a motorboat which can make 5 kilometers per hour in still water. So his boat is still that direct. They did not say a man a man maintaining 5 kilometers per hour in still water moved across. They did not say anything like across. Or they did not say a man Cross, no. Wishes. Wishes to cross. If I wish to go to the north, and as I'm going to the north, and maybe I now come and meet Odo, or maybe I have to, God forbid, I have to even sleep on the road. In my mind, I want to go to the north. Is it not true? But did I now go straight to the north? I have obstacles along the way. So you must know when they said crossed. That cross means perpendicular. Straight up perpendicular. And when they say made this with the boats, rowed the boats, did this with the boats, once you hear he's doing anything with the boat and not crossing with the boats, my dear, that boat is at diagonal. That is what I'm saying. And that is how the physicists made it that you should maintain it. That it means that whatever he's doing with the boat that is not crossing with the boat or across with the boat is not vertical but at an angle. You need to note that. So, any other question? Okay, in absence of any other question, to find the time is still using our normal formula. S is equals to UT. Please, as we start kinematics tomorrow, we will prove all these equations. I will not be teaching you that when you talk about mechanics, that we have what we call kinematics. You say it is motion of a body without paying attention to what? Force causing it. Should be? Why the other one is motion of body with reference to the force causing it, that is dynamics. But tomorrow's class, I will not be teaching you that kinematics is simply talking about equations of motion. Why dynamics is simply talking about the laws of motion. So I will be explaining all the equations you see us doing. So when we are done with kinematics, we do projectile motion. After that, this week, our budget for this week, we enter circular motion. So, I'm the one calling the shot. Now, is it not Wednesday that we call shot for new class? Have you forgotten? Our new students class is always Wednesday now. Is it not true? We normally fix this Wednesday. Sometimes we do it Thursday as well. But the problem with our physics class is that once we start it, you'll be getting sir, this one, sir, that one, sir, this one. I like carrying everybody along. In as much as I might not be able to carry everybody along, but I need to try. Before you know it, we've spent all the time. So if you can be cooperating with me, paying critical attention, so that once we pass anyone, we pass it. So please, using S equals to UT, try to make this subject of the formula. You see that you have T equals to S over U, shall we? And we say that this S is for the horizontal, the displacement on the horizontal. Is it not true? And the U is the velocity on the vertical axis. Please, go and note it somewhere. Why is it so? Because of the fact that if this man had to move if he's moving this thing now from here towards this axis, he has been able to cover from here to here. But look at, as he's doing that, the boat has covered this vertical distance. And the distance we are looking at here is not distance, but velocity. Okay. Which one is what if? We're always going to resolve y. Didn't we resolve y in the other one? Eh? You know here when we did it, we got y and we used it to solve and it still gave us the same angle. Anything you want to ask me before what if you solve it, don't take the class back. Watch. If you do it, it's not working for you, you do it well. It means you are not doing it well. Now, please, for us to solve this time, we need to get what is happening here. Hope you know. And how do we get it? By using Pythagoras. By using Pythagoras. All those people that normally do what if, have you ever, like on your own like this, when you want to eat, you say, instead of using spoon to eat it, and eating directly from the plate, you now say, what if I pour it on the ground? And start eating it from the ground. Since imagination wants to kill you. So you do it that way. Because your what if is getting too much. See, we will do it now, after we find the time. whatever we have, we use it to do it. Let's see. So I have r squared equals to x squared plus y squared, and r squared is 5. So my x is what? But you see that I don't know y, Shebi? Please, no matter how I answer your question, that is me joking about it. If you don't ask question, what is the essence of teaching? It's now comedy. Eh? It has now become live comedy. AY show. But I ask. Okay, you thought is it this one? No, this 0.4 is distance. They told us that this thing now, read the question, they told us that the parallel bands are 400 meters apart. Is it not what they gave us? That's it now. So, in fact, see, do you know how you'll be knowing all these things? You don't even need to be thinking about it. What you just need to be doing is, if a question is given, be looking at the units. Be looking at the units given. If I see kilometer per hour, they are talking about velocity. If I see meter, they are talking about distance. That's another way to be doing it. And it will be easy for you. So, I have 25 equals to 9 plus y squared. So if you do this now, you have 25 minus 9 equals to y. 25 minus 9, 16, Shebi? Y squared. So if you take y is equals to what? So, and you know that when we used to do this, they are all in kilometers, Shebi? So if they are in kilometer, that means that what I have here is actually Shebi? Now, if I wish to now get that my time using the formula, I'm now going to be having distance on the horizontal. See, is equals what? 0.4 kilometers, Shebi? All over 4 kilometers. Now punch it for me. 0.1. You see what we have? 0. Okay, but remember that this one, that is in seconds, Shebi. 0.1, wait, so, hour, Shebi? Thank you. 0.1 hour. But let's try to convert hour to its SI units. Shebi, SI unit of hour is seconds. Well, let's try to convert. So I have 1 hour is equal to 3,600 seconds. So, let's notice 0.1 hour should be equal to x seconds. Is it not true? They gave us the answer there in minutes, right? But let's learn how to convert in seconds and learn how to convert in minutes. Fear not. So, as you learn this thing, there are so many ways you can go about it. But that's why it's learning. You can run around, get what we are doing. So, go here, cross multiply. So I have 1 hour x seconds is equals to 3,600 times 0.1 hour. This one is in seconds. And what I'm looking for is, so this should be getting out. So this times this is x seconds. That is x seconds. Because 3,600 times 0.1. Huh? 3 get it? 360 seconds. And you know that if we don't want to convert to minutes, we can still do it by saying 1 minute equals to what? Oh yeah, now. Hey. 3. Somebody wants to ask me what if a minute is 360 seconds? Now you know. You will be running around now. Should be second. So 360 seconds will be equals to x minutes. Why we are doing this is because we want to convert to the units given to us. So if I cross multiply, I'll be having 1 minute times 360 seconds is equals to 60 seconds times x minutes. And we know that what we are looking for is minutes. So seconds should get out. So by the time we want to make x minutes, the number of minutes we are looking for such a formula, we divide by 60. We divide this by 60. 60 will cancel 60. So 360 divided by 60. So this will give me 6 minutes. Please, do you know one thing I want you to take away from this class? If there's nothing you take away from this class, what I want you to take away is that the subject called relative motion is just a part of motion that is too simple. And that is why I started with it. It's just too simple that once you understand that it's either going this way, or it is going this way, or when it is going this way, finish. So when we finish, I will summarize. And when I summarize, you now know the takeaway formulas to have in mind. Just 3 things to have in mind. So let me give you one now to solve for me. Huh? Somebody like you is not even supposed to understand. Do you know why? It's a joke. Don't go there. Once I'm teaching you, I've noticed it. You are writing. Once I now start saying it is too simple, you wake up. And I tell me, I don't understand. How can you be writing and be understanding me? You need to always pay attention. There are some things that you just need the visual, like the visual aspect of it to be in your head. That is just what you need. There's nothing big I've done here. Hope you know I've done nothing big here. The only thing I'm doing is simply, whenever I want to find time, I must use S equals to UT. But unlike when you are doing normal motion, where you know that it is always one object, maybe moving, you are checking. This one is still boiling down to what relative motion is all about. Motion of two bodies. So you'll be checking, maybe, in this case, we are saying that whenever you want to find time, you'll be checking time in respect to the distance on the horizontal axis and the velocity on the y-axis, which if you check, you now see that you've ended up having that your 2 dimension. And we told you that this particular type of relative motion we are doing is when we are talking about 2-dimension relative motion. So that is it. There is no how you want to do this. And you understand relative motion and you want to find the time. And what you are doing is you now coming to be doing, you get distance on the horizontal axis divided by displacement on the horizontal axis. Who is deceiving who? You've ended up doing everything on 1 dimension. It's not right. So when you are doing this, to find the time, it is very simple. You must compare the distance on the horizontal axis and the displacement on the vertical axis. That is just how you find your time. That is the velocity on the vertical, velocity on the vertical axis all over displacement. Shebi, or is it displacement first? Displacement on the horizontal axis all over, velocity on the vertical axis. You explain, work with them all your and drop. Let me give you one. Solve one. If you solve one, maybe, possibly, you will start to comprehend. Try to solve one for me. I will not solve this one. Try to see if you can solve one for me. I know that in secondary school, sometimes, you did this course, but sometimes they just, once they talk about bearing, they leave it. So let's go into all those types. But before that, solve this one for me. Exercise 3. Are you there? A man sets out to swim. Number 16. Number 16. New physics workbook. Do you know why? Do you know why I like this? I'm coming. Do you know why I like this new physics workbook? In as much as he didn't touch much of equilibrium, but he tried to touch everything if possible. Compared to the first one, the old one, I don't know what they did there. If you ask my students before now, years before now, once I'm teaching them, I'll be telling them, I don't know why they are repeating questions like this. You will solve one in that old one. The same thing you solve. You just skip 2 pages, solve exactly the same thing. Skip 2, solve exactly. They repeated it plenty. If you check my YouTube, you see I've uploaded video on that. I saw that one. This new one that came out this year, I will still solve everything and upload. So I prefer this one. It touched all the topics compared to that first one. That first one just focused on motion. In fact, it just focused on chapter 1 to chapter 5, finish. It didn't touch much of gravitation, nothing on continuity, nothing much on work, energy and power, nothing much on friction. But this one, it touched it. So let's look at question 16. A man sets out to swim across a river. Question 16, new physics workbook. A man sets out to swim across a river 0.4 kilometers. Hey, what's in say I'm a corner? What effect to the river? Man, they collapse. I'm going to give the last 2 years. They get collapse in agri faculty. No person don't collapse here. Okay, when you solve this one for me, a man sets out to swim. So that we do maths. A man sets out to swim across a river 0.4 kilometers wide at right angles to its parallel banks. So you take this question, you solve it as an assignment. Tomorrow's class will solve it together before we enter kinematics. Yes, I said a man sets out to swim. A man sets out to swim. A man sets out to swim. Across a river 0.4 kilometers wide. A man sets out to swim across a river 0.4 kilometers wide. Shebi, my own is to be reading. Your own is to be writing what I'm reading. My own is to interpret it so that I use it to solve. A man sets out to swim across a river 0.4 kilometers wide. Yes, 0.4 kilometers wide. I'm going for that. 0.4 kilometers wide. See this part of physics as if you are doing engine drawing. Shall we see it? I've outlined it. 0.4 kilometers wide. At right angles to its parallel banks. See it? He sets out to swim. The river 0.4 at right angles to its parallel banks. He can swim at a steady speed. Do you know one thing? Yeah. This one said, assuming they did not even put swim across a river. A man sets out to swim across a river. Did I say that? Assuming they did not even put set out to swim across a river. Notice that they are telling you at right angles. Automatically, we are no longer doing this thing. Are you seeing it? We are no longer doing this. What we are not doing is this. This is the river. The man swimming. He can swim at a steady speed. So here with the man now. So Omuvo, Azuna Manamiri, 2 kilometers per hour. In still water. But there is a current. Do you remember when I said current? River flowing. Helicopter moving. Shebi? But when you hear helicopter moving and you hear wind blowing, the wind blowing is going this way. Do you remember when I said upstream going this way? So the same thing that upstream is doing to maybe boats or river, that is the same thing that wind blowing is doing to helicopter. You notice all these things. So the same thing when you hear upstream, what this upstream does to river, that is something that is moving downstream, current moving this way. What it does to river is what wind blowing does to something in the sky, like helicopter, or maybe you see a question that says a bird flying. But remember that helicopter moving, currents, river flowing. This way. So if I know that they said in still water, but there's a current flowing, that means the current flowing is the same thing as saying is the same thing as saying river flowing. Current flowing at 1 kilometer per hour. So in this case, you can now see that even if you want to do anything that has to do with Pythagoras, this is what you're going to be looking for. That is, you're going to be looking for. Another name for this thing, when you see this kind of question, or all these things that we are finding here, all this kind of thing, can you hear me? What they call it is ground speed. So if I have to find arrow here, another name for it is ground speed. And another name for those things we are finding that we call direction is what? Another name for direction when I'm dealing with relative motion is what? Hey! Jesus Christ. I've said it too. Osheba, eh? Osheba. You'll be helping us or to be helping you. Please, we want to make sure that there is no part of your topic we did not touch, and that is how we do it yearly. Do you know why? When you are able to face your problem over and over, or they hard today, or this smooth small tomorrow, or this smoother next tomorrow, before you know it, it will be very smooth. So that is why I tell students, what you are gaining from learning or encountering question, when you meet it the first time, don't see it as hard. Try to meet it over and over. What you are gaining from that is what we call experience. And that experience is what will make it that as you are solving questions, you are not just solving with just your knowledge, but with experience. So with that said, I want to believe that all we've done today under relative motion is just the case 1. Hope you know. That's just what we've done. Case 1. So tomorrow we'll look at case 2 and case 3. Then that same tomorrow we'll be entering kinematics. Who gave me this? Okay, thank you.